So we're going to continue solving systems, but now we're going to use what's known as the elimination method. Now, whether you realize it or not, you're gonna like the elimination method. It's easier than the substitution method. So, yeah, sorry I didn't show you this sooner, but you saw it in algebra, and what we can do is we can use this method to eliminate a variable. So, look, if you have a system like this where the two equations are both in standard form, and neither of the equations is necessarily solved for y. Now, you could solve the second equation for y, and you could substitute, yes, but instead, look at how these two equations kind of line up. Look how the x's line up. Look how the y's line up. And then over here, we have the constants lining up. You see, what we can do is we can add these equations together, and by doing so, we can make a variable eliminate. Now, that's only going to work if you have opposites. So right now, the x's, 2x and 5x are not opposites, and 3y and negative y are not opposites. But they would be if this was a negative 3y. Well, we can't just put in a 3 there, but what we can do is we can multiply the whole equation by 3. You see, when you multiply the whole equation by 3, you get what you want. You get a negative 3y. Now, you also get 15x, and you also get 33, but the whole point here is that we get opposites. Now, you have to kind of ignore this equation. It's almost like it's been changed. Now, we're going to add the equations together. Again, I have to ignore that one that I changed. So, add your x's, you get 17x. Add your y's, well, they eliminate. And add your constants, and you get 51, which means x equals 3. Now, of course, now that you know that x equals 3, you can always plug that back in to one of the equations. I wonder if maybe you want to plug it into the equation I just rewrote. Yeah, if you plug that back into that equation, you can solve for y. Honestly, you could plug back into this equation also. I'll tell you what, let's plug back into the top equation. We're going to plug in 3. That's the x value that we just found. And it's my barking dog. And we'll solve this for y. Do a little math, subtract 6, divide by 3, and of course y equals 4. 3, 4. So the elimination method. I don't have 3 or 4 steps to follow for you to copy down and follow. Instead, we just want to realize that the goal is to have opposite variables, and those opposite variables will eliminate. Now, what if we have a system with 3 variables? Well, we still can add and make something eliminate, but what we want to realize is that we're going to have to do this twice. We're going to have to, just like the substitution method, we're going to have to do the process twice. So let's first of all label these equations A, B, C. And I want you to notice something about equation A and B. Yep, you got it. They have opposites. Now, since they already have opposiits, just the way that they are, I'm going to add those two equations together right now. We're going to add A and B. Let's kind of organize that a little bit. We're going to do A plus B. That's going to give us a 3x. The y's cancel. The z's become a minus 2z. And, of course, the numbers add to 5. Now, look what two variables you have. You have x and z. Look what variable canceled out. Y. What that means is that I need to do that again. I need to make y cancel again. But I need to do it with like 2 other equations. Now, what do you think? Can we add these 2 equations? We can. We just need the y's to be opposites. We need a 2 right here. Now, again, I can't just put a 2 there, but what I can do is I can multiply everything by 2. Now, I'm kind of writing over top of the numbers. It's not necessarily the greatest idea. Really, what we should do is we should rewrite equation C. So let's do that. Let's actually rewrite equation C. We're going to multiply the whole equation by 2. We're going to kind of get like a new version of this equation. 2x, 2y, 4z, and negative 8. And we'll call that equation C1 because it's kind of like a spin-off of equation C. What are we going to do? We're going to add B and C1. Okay, that's because when you add B and C1, we get 4x. You get the y's to cancel, that's the whole idea. And then you get your z's to be 5z. Kind of circling these numbers just so you don't lose track of what it is I'm actually adding. So make sure you add 7 and negative 8 to get negative 1. What do we have? We have a new system. It's a smaller system. It's a simpler system. And we can use the elimination method again. Now, remember, the elimination method, that's when you add the equations together. But you want something to be an opposite. So I'm going to need to change some numbers around. Now look, 3 and 4, they're not opposites, but the closest number they can become would be a 12. And look, 2 and 5, they're not opposites, but the closest number they could become is a 10. And so we just have to decide, do we like 12 or 10? I'm going to go with 10 because I already have a negative sign on the z's. So I'm not going to multiply by 10, but I'm going to multiply by a number that gives me 10. 5 times negative 2, that's going to give me 10. It's actually going to give me negative 10. And then 2 times 5, that's going to give me positive 10. We're going to get some new equations here. 15x, negative 10z, 25, 8x, 10z, and negative 2. Okay, lots of numbers are changing. Got to be careful because obviously one little mistake throws the whole thing off. But now I can add these together. The z's are going to cancel. We end up with some new numbers like 23 and, 23x and 23. The z's canceled out. Well, finally, we know that x equals 1. Now remember, once you get your first answer, you're on the road to the finale here. You know, you just need to plug 1 back into one of the equations up top. If you plug into that green equation, plug in the number 1, you're going to end up being able to solve for z. I think it's going to work out pretty good here. You basically get 5z equals negative 5, so z is negative 1. And now that I know z is negative 1, and of course x is still 1, I can go back up here and see if I can find y. Which equation? The c equation? I would agree, I'd plug into the c equation. So it's going to be x plus y plus 2z equals negative 4. I'm just going to recopy it so I don't forget what it looks like here. Oops. Oh yeah, x plus y plus 2z equals negative 4. And then we'll plug in 1. And we'll plug in negative 1. So what do we get here? We get a 1. We still got the y. Still got the 2. Of course, now we're going to get negative 1 right there for z. Just got to keep track. I think this is going to work out nicely. This is 1. This is negative 2. You got to add those together. That's negative 1. You can just write that as minus 1 if you want to. Add 1, and we get negative 3. So we have our 3 values. We can write them as an ordered triplet. X, Y, and Z. Now don't forget that those 3 numbers, 1, negative 3, and negative 1, they work in all 3 of the original equations. We really should check that, but just don't forget that if you plug that back in for X, for Y, and for Z, it will work out to be negative 2, and it'll work in all the equations. Let's do one more. Okay, now, yep, it's kind of special. In fact, it's supposed to be easier if we just take advantage of what we got here. Look, whenever you have an equation with two variables, you want to take advantage of that, okay? In other words, the variable that's missing, it's the z, right? The variable that's missing, that's the one that I want to cancel. That's the one I want to cancel when I do my first step with the big equations up here. So, I know those x's are opposites, but that's not going to help because I don't want to cancel the x's. I want to cancel the z's. How do you cancel the z's? Wouldn't it be nice if one of them had a -2 on it? Okay, well it will. It will once we multiply everything by -2. Okay, so I'm going to actually just write that up above. Everything gets multiplied by -2. I should have labeled these equations, so we can label this one as A1. Now what we're going to do is we're going to add A1 plus B. Now remember, the reason we're doing that is because these z's are going to cancel. And when they cancel, I'm going to have something really nice. I'm going to have just x. I'm actually going to have -3x. I'm going to have just y. Actually, I am going to just have y when you add those. The z's cancel. Now, don't forget about these numbers out here. They're called constants. And honestly, they sometimes are forgotten. So we get the number 4. But look, I don't have a z. And that can now work together with this existing equation C to create a nice, simple system. I don't have to do it again. I already got 2 equations with 2 variables. So we're ready to rock and roll with some simpler algebra. Now, wouldn't it be nice if one of those y's was a negative? It can be a negative if you just multiply the whole equation by a negative. And sometimes I'll see students, because I think that it's not too hard to do, they'll just kind of switch the sign on everything. As long as you keep track, yeah, that's what happens when you multiply by a negative. So we'll add those equations together. The x's add to 7x, the y's cancel, that's the whole idea. And over here we get 0. Now it's funny, the number 0 gets a bad rap, but it's a number. And if I divide it by 7, I just happen to still get 0. Listen, x equals 0 is a legitimate solution. In fact, it's really nice because if I plug it back in, maybe back into that blue equation, if I plug it back in, well, it's just going to make half the equation wipe out, right? That's just going to equal 0. I get y equals 4. I just got my second value. So I got 0, I got 4. We can just go plug these back in to go get z. How about equation A? I mean the original equation A. That one was kind of the easiest one. What was it? X plus y plus z. Was it equal to 2? So I can certainly plug 0 in for x. I can plug 4 in for y. And we're going to solve for z. Let's show it. You get 0. You get 4. Still have z equaling 2. And I'm pretty sure that means that z equals -2. So, the elimination method. What do you think? A little easier than substitution, isn't it? Okay. Keep in mind that the goal is to have opposites. And when you have opposites, you can add those equations, make the variable cancel. A lot of times you have to do that twice. Okay, that means that you have to add a second pair of equations. Maybe just go back to example 1. First we added a plus b, right? First we added a plus b, but then we added b plus c1. That's like a whole different pair of equations. So you have to add twice normally. That makes the variable cancel out twice and gives you 2 equations. Of course, I didn't have to add twice here. I didn't have to eliminate twice because equation C was already 2 variables, so kind of saved me a step. All right, well, it's time to try those 4 homework problems. I want you to use the elimination method. See you next time.